current era of information, digital data has become an essential component of everything we do. In most current systems and services, we rely on centralized databases in order to store and access the data we use. While convenient on paper, centralized services pose some risks. Centralized services create a single point of failure, meaning a disruption to the server is a disruption to your services. Ownership can also be a concern, since your data is often hosted through third-party providers, and you must trust them to guarantee accessibility and to maintain its integrity. Scalability can be challenging as well, as generalized perpetual fees for set amounts of storage can become wasteful and expensive. An ideal solution for many use cases, especially in the context of Web3, would be to store data on the blockchain. This would ensure that data is secure, immutable, and democratized. Storing data on-chain is inherently decentralized, distributing storage across numerous nodes in a network, removing the risk of a single point of failure. Despite the benefits, traditional blockchains have very limiting block capacities, inefficient and expensive methods of reading and writing data, and typically utilize one chain for all transactions and storage. For these reasons, on-chain storage is usually not feasible. But this is where Chromia comes in, offering scalable and reliable on-chain storage solutions. Chromia is literally built different, designed to take a relational modeling approach to handling data. When it comes to handling data, Chromia is fundamentally different in two significant ways: Chromia's modular multi-chain architecture, and the fundamental program design using RHEL, or relational language, Chromia's specialized programming language. When it comes to architecture, Chromia assigns each dApp and system process its own blockchain, which are then validated in clusters, then on the overarching system chain. Protocols are also in place that allow for interchain communication, allowing dApps and components to speak to one another. Because of this structure, dApps can have entire chains or data layers dedicated to storing metadata in conjunction with its core program chain. The modular nature for this model also allows for more chains to be added, enabling horizontal scalability to ensure more storage is available when needed. Bringing data on-chain means it's decentralized across many nodes, immutable, and prevents one central entity from having control over your data. While this was a challenge for traditional blockchains, Chromia's scalability and modularity make this possible. Now, when it comes to Chromia's program design, the RHEL language constructs data in a fundamentally different way than other blockchains. While other blockchains construct data in a list format, RHEL programs are translated by Chromia's infrastructure into tables, meaning data is automatically constructed and recorded in a relational format similar to traditional databases. This means that data is always indexed and organized, making querying, reading, and writing more efficient and less expensive. Chromia for data is already being used in a number of different capacities, but a great place to experience it firsthand is Chromia's Filehub. Filehub is a prime example of how Chromia's strengths can be leveraged. As a dApp, it consists of two key components: a Filehub blockchain that manages the index of where files are stored and what storage has been paid for, and two or more file chain blockchains that act as the actual storage where files are kept. Leveraging Chromia's modularity, additional file chains can be added when storage demands increase. These two blockchain types communicate with one another to facilitate on-chain file storage. The chains have space to handle their own tasks, but work together to make the system work. This demonstrates how Chromia's design and architecture can be used for on-chain storage. With all that said, let me show you how you can get started with Filehub.